2:15 to 4 and from 4:15 to 5:30. We will have 2 tutorials. So once again, I will welcome Dr. Vijay Khupsisi for the tutorial classes. Over to you.
Good afternoon, everyone. I think you guys have a good meal. Wow, nice. So, today in the afternoon session, we will talk about two tutorials. Right? So, in the sense, in the tutorial 3, I have mentioned it is little bit focused on the heavy metals in industrial waters. First, you should know what are the heavy metals in industrial water, how you impact. We have studied here that they are little for biological treatments as far as possible. Who wants to convert the sludge into manure? What are the consequences? How this is affected their economy, and also the disposal issues. So the all that those of the some of the things we have already discussed. We will see some of the slides may be related to the removal as is concerned and how it is categorized. That is all in this tutorial. What are heavy metals first? We would like to know what are the heavy metals, what are the sources of metals, how it will affect our biological treatments, and also there are certain treatment process to remove them. That is why the industries which are producing these heavy metals are put under categorical industries. When we say that categorical industries, in the sense their volume doesn't matter, whether they are producing just 1,000 gallons per day or they are producing continuously or the industry is producing intermittently. Their discharge may be less, but they are not allowed to discharge it to sewer lines unless heavy metals are taken care. Most of the metal finishers, they have metal issues in their discharge, but their discharge is small. In that case, we have a solution for that also. We visited common effluent treatment plant earlier. In the common effluent treatment plant here in our earlier visit, we saw there was a removal of heavy metals and the sludge or the settled heavy metal is collected in the tank. Is it easy to collect heavy metals? But disposal is a problem. You cannot have a treatment for small industry. This is always a problem because to treat that is difficult. What they collect in a system and they do off-site disposal. Off-site disposal is, there are reputed companies which operate under regulation. Who is taking this? What are the regulations? What are the criteria? Whether they have an authorization. That is one thing. If they are collecting, what they are going to do with that, that is important. you know. If it is a heavy metal, they will collect in one place because they are expensive to treat. However, some of the toxic substances, clinical waste, hospital waste, we do thermal removal, we do incineration, expensive, but contagious. So in that case, we'll have to make sure that that is disposed of properly. Anything which is coming from the hospitals, right? Because it is contaminated, but volume is small. But every hospital clinics, they do not have the incineration facility. Then they collect it and taken by certain vendors. They have a big incinerator, and this is this. How we do a common effluent treatment plant in the same way we do it for hazardous, but the regulations are slightly different. The volume doesn't matter much, but they cannot be just left out to the environment. That will affect the water quality and also the human being. It may cause damage, it may create issues. So that is why we have to be careful in taking care of this. Even not only hospital and clinics, I mentioned earlier about the dental clinic also. We have a regulation where there should be amalgam separator, which are more than 99%, but one time authorization. We want to track, right? We don't want to leave any loose ends, right? You have a system. It is responsibility of cities. They must know. That is what I said. We want in the survey, what we do in the inspection, we want to track every wastewater. If it is non-harmful, you are okay. But you have to make that determination. If there are many oils in the clinics, if they just drain it, they will remain. You end up in the river, lake, sewage treatment plant, just pass through because you don't have any measurements for that. This is not built for that, in fact, and you are not measuring. So they will end up in a place where they cannot be measured. Why you want to take that in the first place there and cause a problem? So that is the idea. For hazardous waste or any toxic waste which is causing damage to the water quality and the environment, we have a separate rules and regulations for that. If an industry is producing a large quantity of waste, we also would like to know where they are storing it and how they are storing it. If you want to store in within the premises, how you are storing, how many days you have to store, right? So that is all there. Whether you want to store it for 90 days, 6 months, then you have to. This is the regulations. How you want to store is also there because you just can't put that in the open area. Okay, that is there. Let us see. Heavy metals are any metal and metalloid element with an atomic density ranging from 3.5 to 7 gram per centimeter cube. Right? So what we are doing, we know in our earlier lectures we were discussing about heavy metals present in the water, wastewater. What we are doing, we are making sure we want to remove, it should not be there. If it is there in the sludge, that you know. But we are going little deeper to understand what they are, in what form they are, what is the quantity, what what are the reservations for them. One of the most persistent pollutant, non-biodegradable in the wastewater. See, it will not degradable at all, and The treatment plants are built for organic waste, degradable material, right? That is why you should be able to understand the BOD and COD concept also. In case of, I'm just, if you go a little back for the wastewater treatment plants, what should be the ratio, right? If it is COD, there are a non-biodegradable. Non-biodegradable, you could do a chemical treatment also. But in the yesterday's visit, you heard COD. But you should have asked the question, which portion is not biodegradable, right? What is the ratio BOD to COD? If it is BOD by COD, then you can find out BOD is degradable. COD is some portion is not required. You have a method. How you will find out BOD? You do the analysis, you will take the sample, put that and seeds, and then you keep it for 5 days and you see the degradation of organic matter. You know the initial concentration. You will find out. But COD, you have a COD reflexer. There is a method where chemically you want to know how much is COD. Chemically, it can be degradable, right? So that is how it is. So it is non-biodegradable. First, in the first case, includes mercury, cadmium, arsenic, chromium, zinc, nickel, copper, and lead. You know the effects of these metals in the earlier lectures. What are its effects? What are the health effects? That you know. We will not go there. You have already seen that. But we want to see the other things related to the heavy metals. Some of them have an essential role in the human and animal metabolism in a very trace amount, but their higher concentration may cause toxicity and health hazard. So what you observe here, you observe they cause issues, higher concentration, issues to the human, and also another thing is added, animals. We are not considered so far. What will happen to animals? We should also take care of. If they enter the chain, food chain, you have seen how it is, the toxics enters the fish. This is also possible with other animals, right? And there are many, researcher here with the background of soil, right? Soil analysis and all. If it exists, what happens, right? These contaminants. If there is a lead, what happens? That's why we are very cautious when we are accepting an industrial wastewater. We make sure that that is treated properly and then discharged. However small it is. That is, if the common effluent plant belongs to this location, then if there are industry, metal industry or any other industry which contributing this kind of heavy metals, then you want to have a local limits. Type of industry you can understand. And you have a lot of guidance document also. You have a guidance document which are the industry, what they produce. You have kind of an idea, right? If a metal industry, definitely there may be metal. Then it may have a chromium, it may have other stuff which is related. So you have an understanding. Then based on that you will issue an authorization. These are the metal concentration. You have a standards, you have state standards, you have a local standards. First you will refer to the state standards. Then you will see based on the river what is What kind of industries are existing? You come to the local limits. So because these industries are prominent, when you are authorizing the industry to discharge, you will see this is probably, it is a common understanding. Then you will dig little bit deeper. This is there, this is in addition to this also may be project. How we will do, what is the other aspect? You will read the manual and you will understand probably these are the heavy metals. And whether any other way, how we will predict? You will see what are the raw materials used for manufacturing. You have that understanding, right? If they are using a certain kind of raw material, you can make a determination. Probably this will also be there. That is fine. You can put a extra. If it is not there, if they are getting a non-detect in their discharge, after so many experiments, then you say, we will modify the authorized. You don't have that. Then you will do. You go other way. First, you don't give a minimum. Then you see, start researching and finding out what are the other causes, where this is happening, where it is going. That is a later part. First, you use your all judgment. That is the professional judgment you can make. How you guys are different from other people, other common person. You can make a judgment because you are in this field. You know about this contaminant, their effects, everything is. You have to use that understanding. You have to put an extra step. What are their raw materials? You can ask any question. Once you authorize, you have the right of entry. You can go and see what they are doing. Where are there any floor drains or where they are disposing? You can ask any question where this will go, where that will go, what you will do, whether this person is training. I go and see sometime. I say, just perform this experiment and see. Can you explain? You can always do. So that is how it is done based on the raw material. You can put certain parameters for measurements. Then if we are confident that this is not there in the system, you can reduce. Okay, we will modify. You need not to do from this onwards these things. So that is how you can, right? So some of them have an essential role in the human elements, animals, metabolism in a very trace amount, but their higher concentration may cause toxicity health. Their hazardous in nature refer to their bioaccumulation nature, biotic system. It is not that one professor was asking me, it is in a very small quantity, but bioaccumulation, it will start storing, you mentioned, it will store in the muscles. So it will start storing this higher concentration, lower concentration, increase 1, 2, 3, 4, 5, many years, 5 years, 10 years, 2 years, then automatically triggers. What happened? Organ failures, suddenly. You won't be even knowing. So for example, the dental clinic, that small equipment doesn't cost much the way they charge. And they don't want to put a hassle also. If you insist, if you are able to locate and find out, you can say they can fix that. So in the post at the source, you remove that. This bioaccumulation for small concentration, as far as the metal is concerned, as far as the toxic substance are concerned, is a big trigger. If it happens suddenly, it is fine. But when this triggers, already high concentration affected, how we will remove from the body? If a person become health hazard like paralytic or any organ fail, how we will do? Who is responsible? That is the way we should think. We should think. So that is why these things are very dangerous. We have put a categorical limit. If there is a fog, there is a disruption, there is a overflow, your efficiency will reduce. They may come out, SSO may occur, sewage may come out of the system, pipe may blast, you will see. But if it is accumulating in the human body, then it is difficult. Suddenly, when it hits the particular concentration, trigger will be. So that is why these are extra cautious has to be taken, and we should always look at the health point. Not only the environment is there, but you see these are the affected to the human health also. Your environment is not going to be safe if people are started suffering. But when you will come to know when the things goes above that, that is there. So physical properties and source. Good conductor of heat and electricity, high density, high melting point, no biodegradable, industrial sources, organic and inorganic fertilizers, sewage sludge, fossil fuel and industrial processes, organic and inorganic fertilizers. So you have a lot of people have an agriculture background here, you know what is organic farming, what is this inorganic farming of using fertilizers, that you know very well. Earlier, our people used to do organic farming. Then they said, no, you should use fertilizers, growth will be high. And people started using the fertilizers. Now they say that people who were said they do not know you have to use fertilizers for growth. Now they are telling you you should go back to organic farming. So, what are the consequences of this non-organic farms? Whatever the fertilizers you are applying to the land, crops, those fertilizers are used completely by the crop. How much percentage is used? To my understanding, maybe 50, 60 or less than that. What about the other portion of the fertilizer? Where this will go? Why this was not thought earlier? You say, always our ancestors were doing organic farm. It has happened in your period only. Now suddenly organic farm. So this is how when you make a determination, some states have prevented this using inorganic fertilizers and all, they are great. They become smart. Unknowingly they become smart because they were not reachable properly. It was very difficult for them to take fertilizers and do their difficult terrain, poor economy. They don't want to sell. They want to sell to the rich people. Easily big market is there. So that is what happened. So then we think about organic and inorganic, organic fertilizers. What about organic compounds? A lot of people with chemistry background and other environmental engineering background, they may be knowing what is organic compounds. There are a lot of organic compounds today. Lot of industries which make metals, fertilizers, they use organic compounds. That is a totally a different area which is the 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 compounds. We know some of them because we have used, they are known for many years, decades, we know. But there are compounds which we do not know. Did a lot of research there on in the advanced countries about some of the stuff on PCB, PFAS. Now they are known, but I want to give a little, a quick lecture on some of researchers are there and people who are there in this field long time, just to have an understanding what is the next level we are going at. So just that will be helpful for you. Maybe half an hour to 45 minutes we can discuss about that was actually earlier not discussed. I felt that you should know that at least. That is coming up next. So still we are thinking about VOD, suspended solids, nitrate, phosphorus, ammonia, but there are other compounds also which are, go ahead, one step ahead about heavy metals. Then you go to the organic compounds. Some organic compounds are biodegradable, some compounds are not biodegradable. For example, you might be doing a chemistry background. There are there, no? Chemistry background. Okay. You know about BTEX, right? Benzene, toluene, xylene, right? We have a regulation stating that benzene, BTEX concentration should not exceed 1.5 milligram per liter. Earlier, BTEX, do the test, 1.5, then okay. But this was missing, that benzene concentration should not exceed 0.5 milligram per liter. Because this was not made earlier, you think that BTEX, we do a benzene, toluene, xylene test at 1.5. But if you go back precisely, understand benzene concentration should not exceed 0.5. So if you do a BTEX test, 1.5, 1.4, if you are getting, so you are safe, right? But if benzene is 1.3 and other components is 0.001, you are already violating. You are already in the risk, because benzene should not be more than 0.5. But you are, what you authorized, BTEX 1.5. You did not say BTEX 1.5, benzene concentration should not exceed 0.5. You didn't say that. These things have happened. I have corrected them. So if you are doing it for many years like that, then suddenly we saw this is not right. Then they have to modify the authorization. That is how precisely all action, put that, study, understand each and every component and then do. If you give it to the industry for authorization of this, they will say, see, I am right, I am doing it. Because you do not know yourself that it is the trigger cost. It will cause a problem, issues. So that is why I say that how thoroughly, as much as possible, you should understand. It is a tough job because you have to keep updated, take the help, and make sure that the things are done properly. So that is what I mean to say. There is always room to make it more, concealed. So fossil fuel, if the gas what is that? Petrol here. So we say gas. Petrol charges increases, suddenly there is a big response. But if it is spread everywhere, you see a lot of seashores and areas are contaminated. It consists of a lot of carcinogenic things in that. That will remain. So that is why you have to have strict regulations for the fossil fuel industry. In the fossil fuel, the coal ash also is there, which causes selenium. Selenium is there. Other things may not be there. Selenium, if it is less than 1 milligram per liter, is if it is exceeding. So those are the things you will have to look for. And then the industrial processes, they use a lot of chemicals in their process. That is also one of the indication where you can search. When you do authorization, you will see what are the chemicals you use. It is just a common understanding, right? You say that guidance line, you did according to guidance line, correct? You did it. But there is also the way to make it more safer. You will see raw materials, what they use. You also see what are the chemicals used. Process changes, new chemicals come in order to, in the coal industry, the process, in the process, coal processing, they use a lot of dryers, correct, to reduce the moisture. So many of the chemicals, or if they are using in the process plant, the PPPs, they have to wear a mask, not this one, which we do in the normal way. Class A protection. That means what? It is more dangerous, right? So those chemicals, when they are using it, do you think that trace will not be in the water? It's a common understanding. So you also put a restriction there, measurement there. If you do not know, it is not necessary to put a limit. If you do not know, you not necessary to put a limit, but you can see the measurements. If they are measuring, you will understand what is the concentration, then you can think, right? So that is the important factor what you should look for. If you have any question in the middle also, you can ask. Huh? Not a problem if anything is. Then sources of heavy metals from the industries process. Now I am giving you the list of industries. You can think yourself what are the major sources, and you also think yourself how the what are maybe the probable contaminants and what will be your job there. It's a commonly you can understand these are the industries are very common, but how deep we go to issue an authorization, right? Tannery industries, I think Kanpur here, lot of leather industry, tannery industry. They produce a high BOD. If that high BOD is getting into the river, what happens? Yeah? Now you are talking about the BOD of 300, 400, 500. What is the normal BOD of the wastewater coming from this leather industry? Maybe 2000. So if you are leaving that kind of a wastewater for many years, automatically how the oxygen content in the river will be prevailed? No, it causes a severe problem. Production of pesticides and insecticides. Someone is in conversation, I understand they were talking about herbicides. Yourself? Someone, herbicides. The traces of herbicides where they will go. Insecticides, pesticides we use all the time, very liberal. Right? We use in the agriculture also, right? But earlier we were not using it. If you compare the apples grown organically and the apples what you eat today, you can find the difference. If you keep the today's apple Even flies won't come there, right? You might have seen any. Right? But if you grow organically, what happens? The shape may not be exactly round, and they spoil little earlier than that. They will never spoil. You keep for months together, so you can understand. Apples are good, right? Fly is not ready to eat that. You keep it, no insects, nothing, anything will happen. So this is how, why this happens, because they are just washed with a certain kind of chemicals. It won't spoil, it will not decay, right? Electronic waste and batteries. Today everyone may be having the 10 phones, might have changed, right? We just discard many computers, right? Every computer is made of fibers, plastic, right? Somebody was talking about microplastic, but the where the problem is there. It is not necessary that we need it, but you're not against that. But the wastewater coming out has to be taken care. Otherwise, if you don't have a solution, send it to a landfill. How long we are going to do that? Now we have to think about, is there any solution? Yes, there is a solution. When you bring a new product, at the same time you should understand how it can be recycled, how it can be reused, right? So that is important. Now you reuse, encourage those industries. No, don't just discard. Government also, we have from the authorities, you may be having a lot of discounts, lot of facilities, funding. Make sure that they are reused, recycled. That is what, how it is encouraged in the water quality, in the water, as far as the water is concerned, treatment of wastewater is concerned, reuse, recycle, reclamation of water, right? Reclaimed water. So these are coming up. In similarly here, you have to do it a extra process to make sure that these things are reused. So we have to think about that then. Otherwise, what you can do, there is a process also. When you buy a car, you put the price for that. Recycle. Yes, you are right. You are not able to do that. You don't want to do it. Okay, you will have to pay that for that. That is important. So that is not happening. That has to be happening. People should know to pay. If they violate, they should pay. So that is how it is coming up slowly. I don't say that nothing is there, but things are has to be moved at a faster rate. So electronics, steel industries, we recycle. That has to be reuse wherever it is stress. There are many processes where you can increase the strength also. You can use a recycled one, or where the less strength is needed, step, right? It has to be mining and smelting. So there also, once you mine, you should not just leave it like that. You will take the good stuff. If you are mining in the coal, you will take the good stuff there. Rest of this is the waste, rocks, waste rocks and all, heaps of waste rock, you will get this. If it is a gold mine, you will take a small gold here and the big stuff will remain there. But at the same time, you should have the ability to make it environmentally right. You will make a big pond, or dig a lot of tunnels, remove gold and other metals and just leave it like that. Happens. Take the good stuff and just go away. Who will take it? Who will remedify that? Who will work on that? So that is why there are government policies also. Even these things happen in the advanced countries. I had to work in a certain place where lot of mines are just left like that. Mining, how that works is, if the cost of your product reduces, they close the mine. If it increases, they start mining. And they will just leave it like that and go away. Dig everywhere and heaps of stuff will remain. Then government started doing whatever their production is there, some 20% they will take out that money. If you do reclamation, then we will pay that. If you don't do, we will do ourselves. But what happened? That law came after so many years of experience. They started doing this. Many companies came forward. If they go away, then they hire people like that. I was in one of that project in a place like Yukon where gold rush is there, lot of abandoned minings. So we went there, we did prepare all the metals, everything was there, just flowing, and you don't have a right to spoil the entire environment, and prepare a report, do a in situ treatment, and also do a remediation work. Then you will have to reclaim that entire area free from the pollution. Then you do a reclamation, and it should look like how it was. That is, then you do seeding. That is a reclamation. It should be like that. You can just dig something and just leave it like that, then all the time the pollution will start. Where it will end up? It will end up in the river. If it is in the north, it will come to the south. Anywhere it will go. So that is how these things by experience started developing, right? So that is why these mining also produce a lot of contaminant. But mining is bad? No, mining is good. But what you do, take the stuff, spend some profit for reclamation, make it safe as it is. So these are some of the concept about these metals. This we saw that. Okay, removal of heavy metals from the wastewater, right? Okay, so we'll just go one step ahead and see what are the possible methods to remove heavy metals. Earlier, what we did, so what are the heavy metals, where they will end up, what they will come up, if it goes to the sludge, what happens? Certain chemicals, if you just leave it outside, what are the causes, what are the issues affecting the human health, animals, right? So then we'll talk a little bit about the possible treatment. Sedimentation screening, physical methods, filtration, microbic separation, right? Chemical methods, chemical precipitation, coagulation, ion exchange, adsorption, solvent extraction, naturalization, biological, aerobic, and anaerobic. So, biological process, why it is a biological process? I said earlier, heavy metals cannot be removed, but organic compounds which are there, they can be used, right? We are talking about all the metals and some of the toxic compounds, right? Organic compounds, many compounds may be used as a source of what it is, source of nutrient for microorganisms, right? It is possible. So chemical methods, if they are not biodegradable, what we will do? We will do chemical precipitation. Many people from the chemical backgrounds They know all this. Ion exchange, adsorption, right? These are the common methods used to remove contaminants. So I have given little bit electrolysis, precipitation method. You do chemistry background people, you will find out which is the best one. Because chemical removal, chemical precipitation are all 100%, 99%, 95% you can achieve. Because you are using a chemical, precipitate. What you are doing? Are you removing completely? No. Your aim is also reduce the toxicity as much as possible, right? Then conventional method for the removal of heavy metal. What are the conventional methods? You see, electrochemical, physicochemical, adsorption, electroflotation. See, electrochemicals, electropotential, electrocoagulation, electrodialysis, right? Then physicochemical, chemical precipitation, ion exchange, and membrane filtration. Right? There are methods where you can do. Adsorption, activated carbon, carbon nanotubes, agriculture. You see where we had been for the treatment plants, they were put inclined tube settlers. They find it more efficient, right? So that's why there are different methods. Don't just think conventionally this is the only way to do it. As the things change, you will try different ways to increase the efficiency, correct? So agriculture waste, carbon, activated carbon is widely used. Activated carbons are used. What is the method for? See, there is a lot of odor issue. Yesterday, maybe in the fiber industry, paper industry, they use charcoal also used. Activated carbon is also used to remove the odor, right? It is possible. There are different ways. There are treatment ways to remove, but only you will have to find step forward. They may be expensive. If the regulations come in, the regulation is there. If you put it mandatory, then people start using it more and more, and the value will reduce. So this is how. That is why when somebody, how you are asking, we should use advanced technology. We should make sure that bring the people of, you know, same who are producing the same wastewater, they can put a pipeline if they are away. It is not necessary. That's what I was saying. Ours is scattered. Now industrial zone is coming up in certain areas, right? There are, air pollution is concerned, noise pollution is concerned. Zones have a different. How it is built, we have in the paper, in the books you have already read. It's a residential zone, industrial zone, sensitive zone, right? Where hospitals will be there. That is the way you do planning, right? But if it is not happening, you should slowly try to safety, and you can make a pipeline and bring together. But somebody has to step up, put the best technology, can collect the money. So that is how alternative is there. That is there. You can always do. But in searching alternative, if you spend decades together, that's of no use. That is why make sure that the things are in place. Otherwise, don't allow unless it is adopted. Do something partnership. Government also should step forward to give a discounts for those people who come forward, funding they do. If they are not doing, give guidance, some kind of stuff. If they are really doing, always there is a way. So that should come up. That is the idea, different methods of. Then what are the RCRA 8 metals? They focus on heavy metals, allowable limits, hazardous waste codes. You can get in any reference also. Is it? You see 1 ppm, 0.5, 0.2 mercury. Don't throw battery cells everywhere. It has to be recycled properly. Otherwise, you see, if you throw the batteries anywhere, what happens? It will enter the food chain. So we run a mercury control programs. Right? So selenium 1 ppm. Heavy metal. In the coal industry, madam, selenium is also one of the targeted one. But you should know here also it is there, everywhere it is there. So that is the idea. Chromium, some people are working in chromium. It should not be more than 5 ppm. It is quite possible. If you find chromium is there, leather industries and other places, you should put that as an element. This is there already. Chemical precipitation, fundamental experiment, a lot of people may be knowing already. So that's why, just added, we have a basic one. Simple schematic of chemical precipitation process, you know how the metals are removed. We add a coagulant to bring all metals together, settle down and then. That is the process of coagulation. Chemistry background people know this. We also done a experiment in your schools, right? And we are there. Same process in the large scale for removing this. Coagulation and flocculation. Coagulation and flocculation. We add the chemical there. How you do in case of water? Coagulation, wastewater is added, coagulants are added, different coagulants available in the system, available in the market. You will add the coagulants, flocculation, flocks will form. Is it? Then by weight they will settle down. Simple logic, right? Then they are removed from the process. Ion exchange, you know ion exchange is the process. Ion exchange particles, cation, wastewater is added. That is how this ion exchange process you know very well. Ion exchange units are there. In the industry also we use in the heavy waters. If it is groundwater, we use the ion exchange methods to reduce, to remove iron and manganese. This is widely used in the industry, right? Flotation treatment processes. Once we do the chemical precipitation, before a discharge you do the filtration. Filtration is one of the process in the wastewater also. When treated wastewater, if you want to refine further and use it for different purposes, if it has to release to the rivers, if you want to use it for a precise activities, some activities where you need more quality water, then we do filtration before disinfection. Then you use it. Right? So all these are followed depending upon the need, what you are using it, this treated water for. Membrane based treatment. Separation capability is different membrane against different pollutant. Nanofiltration, ultrafiltration and reverse osmosis. We talked about reverse osmosis. When we use this reverse osmosis, if there is a high TDS concentration, expensive, but it is not expensive for people, just some percentage of their profit they have to see. High TDS, if the groundwater limits are 500 mg per liter, if the water has 1000 per mg per liter, you cannot add a 50% and discharge. You cannot make a dilution as a solution, right? That is, even if it is, or accepting it is wrong, you cannot do that. But you can adopt a reverse osmosis. In one of the pilot plant, in removing the water from the coal industry, we did a pilot plant where we used a biological process, reverse osmosis process, and another kind of a biological process. We compared. See, what is our main focus? Economics is there. First, you need a water quality, what you wanted. Of course, efficiency is high in reverse osmosis, but expensive. But very purpose must be solved, right? The wastewater is passed through the inclined membrane, and the concentrated which is remains here on the back side, it is put back to the tailing ponds in the coal industry. Then this water is used, good water, right? So there are different methods, separation capabilities of different membrane against different pollutant. You will see what kind of a pollutant is there. If it is a toxic, you cannot talk about the economics. First focus is on the water quality. Technologies are available. There are many technologies. You should be able to screen that technologies. I will show you another technology in the next tutorial. See, that is where we were thinking about treating one of the most toxic pollutant. There is a technology, there was a success story for that. There are available technology. You cannot say that how to do, how, if it is available there, who will, but it has to be there. There is a way for that. We have already used. There are no technology. That is why today I was telling the researchers, do a thorough understanding what you are going to do, whether this is available, already done, what is remaining, that you focus on that. Right? Dissolved air flotation, DAP, we are using it. In DAP is used dissolved flotation, air flotation. Yesterday you saw there are aerators fixed at the bottom. If the depth is high, aerators are put on the top if the depth is less. But DAP is in a machine where the oxygen is supplied. Organic compounds are converted into a stable compound. You are reducing the BOD loading. Then you can discharge. There are food industries. I think I gave that example in the very first tutorial. There were two issues. The different tributary industries were discharging to a one industrial wastewater treatment plant. City said, oh, we have a lot of industry, we will do one more specifically for industries. How we do common treatment, then for the whole cities. Number of industries started discharging, and one of this food processing industry, they have a high suspended solid and also BOD. But when you give an authorization, what happens? You have the right to reduce the suspended solids and then discharge. Otherwise, all things will be disturbed. If one industry is doing like that, what you will do? You will do big primary settling tanks, and then the BOD is also high. If an industrial receiving industrial wastewater treatment is not capable of taking that BOD, If you are discharging it to the receiving wastewater treatment plant, you cannot put a high BOD anytime. They said that we can handle only this much. The rest you will have to treat. How you will treat? Once the total suspended solids are removed, then you will pass through DAP and then discharge. Bring it to certain level, right? Then make it compatible what for it is designed. So here pre-treatment, rapid mixing, you will remove particles and they effluent. Recycle and you put oxygen here so that they are the organic compounds present in the wastewater is reduced. So once you say that organic compounds or organic loading has to be reduced, then you have to adjust the pH, right? And what you will have to do, you have to create an environment, but you are only adding the oxygen. Organic components are already there. But in the activated sludge process, it is slightly different. Microorganisms and aerators supply oxygen here. But here, already there, because it is a food industry. That's why you are supplying an additional oxygen. Right? You have to create an environment. What environment is needed? You need an oxygen, organic matter, good pH, temperature. So then organic compounds will remove. So what we see in this removal of heavy metals, we see what are the concentrations, what are the different methods. They are not biological methods. Biological methods are used for organic compounds. I have added organic compounds are also in this. But heavy metals, you have a chemical precipitations and other adsorption and all this, ion exchange. Those are the different methods available. If you are asking me how we will come to know that if an industry is discharging, your treatment plant is designed for certain parameters, then you can always find out based on what chemicals they are using, what is their product, what are their raw material, what is the guidelines. You can have an understanding what may be the probable pollutants it may be having. Then they can do this. That is left to them. They can adopt a chemical methods. I said one, I shown you one industry which did reverse osmosis and then discharged. That is what the pre-treatment and industry and receiving municipal wastewater treatment plant has an understanding. You do remove toxic, make it compatible, we will take care of it. You just cannot discharge like. Different industries are there. There may be food industry, there may be this industry, there may be metal industry. You can have a solution for it. So that is what we dealt in this process. In this lecture, we covered what are their concentrations. There are documents available, what should be the limits, how those limits are developed based on research, based on several years of data. These are the probable number, right? So, which are dangerous to the human health and also to the environment. You have that document. So that will give a guidelines. There is a list of industries from where these kind of heavy metals comes out, organic compounds which are toxic. You have that guidance. You also have to do individually find out what are the raw materials used, chemicals used, then you prepare the authorization. Right? That is how these things are dealt. There are many possibility. You can do good things here, and also there is a solution. You see, what I want to show you is there is already a process. There is already a inbuilt system. Only that has to be adopted here based on the situations. You just don't say that it is not available. It is available. See, other countries have done. Other places are available. Here only there are many places where they will be available. You can always give an example. There should be more exposure, more conference. Industry people should come together, attend that. There are always the technical shows going on and people display these are our new technologies, right? So the only thing is go and adopt. Every industry has to be now, if you enter any industries, and it is your responsibility to all the time search new technology. Gating process. You find out what are the technologies available, then you see what quality produce, efficiency and the cost, then you make a determination. This can be possible. Then there's also a regulation. You saw that the case studies, why I'm showing it earlier, the same group people were doing a certain methods which was not working. It was maybe working for some percentage of concentration. As the volume increases, it becomes inefficient. If you find out and show them how how they can do it, little feedback. There are technology. You put a group of people, smart people, they will find out these are technology. They did. They took out the earlier one, they put the new one. Reduced from 6,000 to 500 milligram per liter. You have seen the exam. So that is, I am showing it. It is possible if you work precisely and put all the things together. Industry can work also, win-win situation, both the successful stories. Thank you. Let me know if you have any questions. Any questions? No. Oh, Mike, please.
Yeah, hello. Sir, what are the challenges they face while discharging the wastewater to this common effluent treatment plant
From?
from industry to common effluent treatment plant? Because treating wastewater in an industry will be a challenging task, but at CETP they may receive wastewater from different industries. So,
Correct.
for example, if it is from a heavy metal industries,
Mhm.
again we will be contaminating the other industry wastewater with a heavy metal.
Yes, correct.
So, like
Very good. Sit down, please. So, I said how the concept of common effluent plant is built. There are many industries. See, each industry has a different issue and each industry has a advantage also. Is it? For example, if there is one food industry and one industry, metal industry or organic compound manufacturing industry, if which has heavy metals, how we will do? So all the industry group will come together, they put the money and they build a common effluent treatment. Common effluent treatment plant is designed based on an understanding it should work commonly and benefit for all the industries. One industry is producing heavy metals, but it is also producing other components. It may be having a BOD, it may be having organic compounds. What you will do, you will say that this is built, this is our capacity of the common treatment plant, then you remove the heavy metals on your own. They will put some chemical, only that portion, only to remove heavy metals, then rest you discharge. Correct? And there are industry where industries are producing very low BOD and they have a high pH, and some industries producing a low pH with organic compound. You will mix all that in a equalization tank, neutralization occurs. You see, if the food industry is there, their BOD is quite high. You need a BOD. Industrial discharge has less BOD always. We look for a higher BOD. Industries which are producing higher BOD, where a lot of microorganism BOD is coming ready-made. And other industries, they have, if a toxic metal is there, they will have to remove and then discharge. If they are producing a low BOD and high pH water, low pH water, and non-cooling tower wastewater is coming in, you can mix. If it is a non-cooling tower, they have a TDS issue, but they don't have a BOD. Right? You will remove TDS and then discharge. That is how I gave an example that. That is same concept of that common treatment plant, where in the city also does the same thing. They build a treatment plant which can treat a domestic wastewater, and they said that for one of the industries, all the residential domestic water is discharged to the city wastewater treatment plant, which has a high BOD, nitrate, everything. It has a capacity to remove this. Then one industry which is producing TDS and rest, it has a BOD, alkalinity, and that is all. It may be having nitrate, ammonia, like that. But they said you remove TDS, then you discharge. This is how. This is how then it is done. Because usually city treatment plants are built 5 MLD or 5 gallon. That is our minimum there. If you want to authorize, we usually authorize for 5 MGD per day. Means 5 million gallon per day. Means 4 times you can say. MLD also 5 MLD. Such a big plant. But they can accept certain portion of small industries they can cover. I've seen the city treatment plant which is designed for 10 MLD, 10 MGD, and there are about 11 industries which are discharging, including the metal finish. Because 5 MGD and the small portion about 10%, 5% is nothing. Right? It can easily handle and treat, but they will be paying a large sum money. Right? You can upgrade your treatment plant, use the best technology, have a good manpower, good analysis, and all the modern equipments. That is how it is done in the big cities also. They have an industry, a company. It is a totally private. A lot of industry discharge. They pay money for that. They take care of it. That is how it is done. Now, when we were visiting the earlier industry, he said this is done a off-site disposal for metals. Means there are people who collect that, and there is a treatment unit who does that chemically. What he does is he collects this sludge which consists of metal all over places. Then he has a chemical treatment plant. He will be charging this much for this much of production of a sludge. He will keep his sufficient margin, and industry also says we will take this headache. Let us go this. We can't do anything for this quantity, but it is there in the regulation. You have to take. You just can't throw it anywhere. So they are happy. I have an industry which does it for the fog. They collect fog from all the restaurants, industries, oil and grease, fat, oil and grease. And they do a lot of byproducts. Collect that, all of them, and we authorize that. So this is how it is done. That is why the very concern was the small and medium, how we will deal with them. You make a provision there for them. You can't expect all the industries should be like the big industry where you are doing. You see a lot of metal industries where They are contributing a lot to the economy, but your job is to help them, right? When city becomes happy, when industries are in, that income is there, but it is city's responsibility also. Make sure, just don't blame them. You have you have to create a facility for them, right? If there is no facility, or if they have to pay more, they don't bother. They say that at least there is a space where we can dispose it. Just for the some minor issue you don't want that industry should perform. What is whose responsibility it is? City also should think. City should not just become happy when industries are there and start collecting money. That is why there are many. If the city doesn't have that money, they can also have enough funding from the state, from the central. That is how we do. Some cities say we don't have to, but they will make sure we will provide you a loan, you give it back. Each city, town should run accordingly. Right? There should be accountability. How you do the accountability? How much revenue it generates? If this city is there, what is the revenue generated? And where you are using it? How many taxpayers are there? It is all interconnected. You pay the income tax, center gives the funding, right? But how many people pay the income tax? It is not. You go to certain big areas, villages, maybe 20,000, 30,000 population, 50,000. No one will pay electricity. But they can say easily, there is no road, who will do it? This is not there, that everything. But how much, if you ask, how much income tax you pay, they will say, what is income tax? You have seen the press reporters, professor? What question they will ask? You don't have a roads, but no one will ask how you do you pay any income tax? Why they will not ask? Hmm? So these are the things. So in a city town also you should run like a industry. If you don't have less funds, okay, you take this much fund. But people living there should understand you are taking a loan and for doing all this. Roads are not good. Yes, I have seen an example. I think may not be relevant, but we have seen many places where unauthorizedly people live, and no electricity officially, no drainage, no authorized land, nothing is there. I've seen a press reporter going there, and a few people were complaining. See, so much water, wastewater here, it is so dirty. Nobody is cleaning. People who were not paying anything, staying, even everything is illegal. So they also say that no one is doing. Who has to go and clean that? So these are the things. And they did not ask, what you guys do, why you don't do the volunteers. Volunteering every once in a week, or you people gather together and clean your area. Why they don't ask? So these are the things, slowly it has to be uh, put into the system, then only it is possible. So there are always a solution. Industry and regulation and the growth all is required, but only it has to be done in systematic manner, in a reasonable manner, in a realistic manner. That is what I wanted to show, because the system is already existing, right? How it has been done. It is not that how we have to do. No need to search how we have to do, right? It is already there. So that is what I wanted to give you little understanding on that. Okay, right. Any other questions? No, one more.
Uh, so we are into this industrial wastewater management, and why to worry about management when we can prevent at the early stage? I mean, at the source itself. Why don't we think about the prevention?
That is the first thing it should come to the mind. That is what I gave a example. You should reduce at the source.
Yeah, what sort of activities we can do?
You can do, for example, I will give you an example of solid waste management. You see, in from each residential area, if the solid waste is generated, right? If you do the segregation at place, it will be much easier, and all that waste should be collected and taken to certain places and recycled, reused. It has to be done. The system, if you don't have a system, they will throw anywhere. That is how many rivers and all banks you see, people just throw it here. So reduction at source is the first priority. No, I agree.
Thank you, sir.
That is how you do. The plastic bags you said you have stopped manufacturing and nobody uses now.
Yeah, exactly.
Huh? And you are putting $5 or $10 per 5 rupees or 10 rupees per bag. Then the people will say no, we don't want. They will start bringing it in. So it is the reduction at the source itself. Then it doesn't mean that that will solve the problem,
It will
but
reduce.
it will reduce the problem. Right? That is how we have to do.
Yeah, and in one of your lecture you said that wastewater will be released. I mean, effluents will be released to this one common STPs, that is sewage treatment plants.
Yeah.
So on what basis they decide, or is there any criteria to decide the amount the industry has to pay to the STP management?
No, that is you can how much simple economics, how much you invest in that, what is the cost, in a period of 30 years, how much you will recover. There is a system for that also. Industries they will not ask you, you first build and pay all the money and then you start discharging. It is not like that. So industries will start coming into that, and then how the house is purchased. You will purchase the house and monthly you will start paying that, right? In a similar manner, it is done that way, right? They can take a loan, and always they take a country itself takes a loan from the World Bank, and they will keep paying in 30 years. Similar way, large or small. Project management is same for a small problem and big problem. Only the complexity will be there, but the fundamental philosophy is same for whether the project is small or big, right? What is applied, the economics for the houses, it will apply for the city, town. Everything is same only.
Okay, thank
That
you,
is
sir.
all. Thank you. Any other questions? Oh, yes.
Sir, as you discussed about these heavy metals, and we have very severe impact and very trace levels through these heavy metals. So, like when we treat them, can we? There is any chance we can reuse them or recycle them, because these heavy metals are also useful in various industries. So, if we separate it in earlier stages from the industries, can we use it for any other for other like industrial purposes?
It is possible. You can recover the precious metals back and reuse. Reuse system is always there. As much as possible, we want to create a byproduct, right? Yesterday only you have seen the example. The waste which is generated, they were using that, they will make it contaminant free, and then they are using it some to
Particle board and
particle
acrylic
board
purpose.
and all. That is how. Similarly for heavy metals also. Metals you can recover. But people you have seen recovering silver and gold, right? Even you have seen people recover it from the, sewer systems. You have seen, though it is just a cost benefit and wherever possible. But you should also do where there is the cost benefit ratio doesn't work also, right? Because of the environment you have to do that, right? So, have to put thank you board. Thank you. So I think you can take a